Alright, question 12g of the half yearly. Here we have a brake pedal. It's made out of metal. I'll colour it in. So this is one solid bit of metal here. You push on this end and this end has to move. They're linked. Okay, they're it's one big piece, it's solid. Okay, in this case, we know from previous experience, and you should know from class as well, moment 1 is always going to equal moment 2. Okay, so in this case here, we need to know moment equals force times perpendicular distance. Okay, if the length given is not perpendicular to the force, we need to know what that perpendicular distance is. I have been very generous here that these forces are both perpendicular. Okay, so that is perpendicular to the beam, or that part of the pedal. So that force is perpendicular, and if you look over here, this force is also perpendicular, which means I don't have to calculate length. I could put them not perpendicular to the length given or the part of the metal, then you have to work it out what it is. So in that case, I've got a force over here, and I say this is moment 1, and I'll do a nicer colour over here, and I say this is going moment 2. Okay, moment 1, in green, equals, come on board, 1 equals force times perpendicular distance. If we have a force equals, I have a distance equals 300 millimeters. 300 millimeters is 0.3 meters. Okay, I'm going to try and get meters. I'm going to go into moment 2. Moment 2 equals force times distance. Okay, force is equal to 200 meters, so the units are correct. And the distance is 60 millimeters. 60 millimeters is how many meters? Should be 0.06 meters. Okay? It is perpendicular, so we can use that. Okay, in this case here, I have 200 times 0.6. So moment 2 equals 200 times 0.06. Okay, that should equal 12 newtons per meter. Okay, that's moment 1. Moment 2, sorry. So moment 1 equals 12 newton meters. In that case, if I go over here, I know that moment 1 equals 12 newtons per meter equals F times, what's our distance? 0.3. Okay, 0.3. That makes sense. So in that case, to find the force, I did 12 divided by 0.3 equals the force. And if we do that, we should get 40 newton. Okay. That was relatively easy because the distances were perpendicular to the forces applied. Normally they're not, but in this case it is, so it is quite simple. Force times the distance given equals force times the distance given. One thing to remember is one force is going clockwise, and what I mean by that is if I use a red pen, this is the way the clock turns in most people's worlds. This force M2 is going clockwise around the pivot point. Moment 1 is actually going in the opposite direction. Hence why I can say moment 1 is going to equal moment 2 because they're in equilibrium. Simple.